All right, happy Monday. On your screen, there's weekly directions. This week's going to look a little bit different than last week's videoed lessons. So the first thing I'm going to make sure that you want to do is watch the video, take notes. You can pause, rewind, and go at your own pace. That way, if I'm going too fast or you need some time to write something down before I change slides, that'll all be available for you. What's going to be a little bit different about this week is that you're going to use the guided notes that have been given to you. To be able to fill out any of the activities or things that you do from the board, basically. And you're going to notice that on some of the screens, there's going to be timers. Anytime you see a timer, that's going to be parts that you should be working on your own independently. If there's no timer, it'll probably say notes, or it'll be me talking about a slide. I'll collect these notes at the end of each week, and that'll be part of your weekly grade. So I'll grade your warm-up and your notes all as one grade each week. That should be the easiest grade that I give you, because if you follow along, take good notes, and provide good information, all you have to do is turn it in. The second grade will still be your weekly bit.lys. These will be graded every day, and then I combine them at the end of the week. Make sure you show your work on a separate sheet of paper and that you're turning those in at the end of each class. So just remember, if there's anything that you get confused on in a video, you're more than welcome to pause it, raise your hand, come get some help, work in a small group. We're still available for you. So at this point, make sure that you have your warm-up paper, your guided notes paper, and your calculator, preferably the Desmos calculator. At this point, I would pause the video and take about 6 or 7 minutes to do your warm-up. Number one is going to be a little bit different, so if you're confused on number one, you can go ahead and skip it. Do number 2, number 3, and number 4. They're very similar to what we've been working on lately. So at this point, pause the video. When you're ready to go over the warm-up, unpause the video. It should not take you more than 6 minutes to complete these 4 problems. All right, here we go. So number one, here's what's a little bit different about number one. You're going to be able to use a calculator for any problem that you would have like this. The key to this is knowing what parts can go in the calculator at which times, because we know we can only combine x's with x's. Common variables can go together, and we can combine constant numbers with other constant numbers. Now, without a calculator, this would be a very difficult PEMDAS problem, order of operations. But the key that they're trying to see in this problem on the EOG is that you're able to use math technology, aka a calculator, to be able to solve part of it. So the parts with just strictly numbers, we can put in the calculator all at one time. We just have to be careful that we type exactly what we see. Now, I'm not going to write plus 7 because that's just letting me know that this is a positive 7. So I'm going to do 7 minus 12 times 2 minus, open the parentheses, 3 to the second power. If you forgot what the second power button is, it's right where my cursor is, this a squared, okay, plus 2, and then we just have to remember to close the parentheses. Notice how our Desmos calculator gives us the answer of negative 28. So right there, we've already solved half the problem just using the calculator. The other part, we got to combine the x's with the x's. So I know that I have 6x minus 1x. Again, the calculator can help you with that. 6 minus 1, positive 5, 5x. So again, the key is understanding on these problems that you can put most of the expression in your calculator. The calculator will do most of the hard work. You just have to remember that you have to do the x's separately from any constant numbers. All right, number 2, the equation y equals 40x models the number of words that George can type in x minutes. Patricia is able to type 375 words in 5 minutes, and we want to see which of these statements is true. So the first thing I notice is that they're talking about 2 people. This first sentence talks about George, and the second sentence, I'll highlight in purple, talks about Patricia. So I just broke my kind of notes in this problem into 2 people, George and Patricia. George, there's nothing to solve. They're telling us the answer to George. George types 40 words per minute. Patricia, they told us how many words and how many minutes, but remember, if we're dealing with a constant of proportionality problem, we're just taking the y value and dividing by its x pair. So 375 divided by 5 in my Desmos calculator says 75. I could say that y equals 75x, but they're not asking for an equation in this problem. They're asking for something that's true or false. So I'm just going to go through each answer choice and see which ones match up. Well, I noticed nothing says anything about Patricia typing 75 words per minute, but I do see in answer choice A, it says Patricia can type 35 more words. Well, 75 is definitely more than 40. If I wanted to find out how much more, all I would do is subtract the 2 numbers. 75 minus 40 is 35. And if I read carefully, it says that Patricia can type 35 more words. That's true. She types 75, George types 40. 75 is 35 more than 40. Obviously, B would be the trap answer, and then C and D, they don't even make sense based on the given information. Number 3, what we worked on last week with our quizzes and everything. So first thing I wanted to do is take this outside -4 and distribute it through my parentheses, being very careful of my symbols. So -4 times +2a is -8a. -4 times -3 is +12. And then I drop down the +10a because it's not inside the parentheses. From there, I was just combining my a's with my other a's, so I had 8 negative a's and 10 positive a's. -8 plus 10 in a calculator says +2, and since there was nothing to combine with that plus 10, 12, I dropped it down into my solution. So you should have gotten 2a plus 12 or 12 plus 2a. And then last warm-up question, number 4, a half circle. That's really important. I'm going to make a note of that. A half circle has a diameter of 12, so I listed my information. And then the first thing I did was think about, well, what formula do I need to solve for a half circle? I know that in order to find the area of any circle, it's pi radius squared. But if it's a half circle, I've got to remember to divide by 2. Well, if I'm using the area formula, that means that I am using a radius, not the diameter. So in my Desmos calculator, and I'm going to show this one on my Desmos calculator because I would put it all in your calculator all at one time. So we have the pi button, 6 to the second power. And then remember, the entire thing is going to be divided by 2 since I have a semicircle or a half circle. And notice, I'm not going to get the trap answer of 113 by forgetting to divide by 2. Because I put divide by 2 right in my equation, it gives me the final answer of 56, and I know I'm correct. So at this point, make sure your warm-up's all good, and then get ready to take some notes because today we are going to pick up where we left off last week. We're going to be working on what are called two-step equations this week. However, before we can get there, I'm going to do a quick little review on one-step equations. So if you remember what to do, take the next 4 minutes, solve these 4 problems in blue. You should get one of the answers off to the side in black. If you don't, you definitely did something wrong. So at this point, take about 4 minutes, solve these problems. If you can do them faster than 4 minutes, good. Unpause the video and check with me when you're ready. So here we go. First one, I have x plus 32. Remember, the goal for this stuff is being able to read the problem correctly. So I said x plus 32. Well, the first thing I always want to do is break that into a left side, right side, and find my variable. My variable's on the left side, and I think to myself, well, what's being done to that variable? It's being added by 32. Well, I know that the inverse or opposite of adding 32 is to subtract 32. That'll make that 32 go away. And again, whatever I do to one side, I do the exact same thing to the other. So -10 minus 32 would equal -42. The second one we had was -4 times x. So again, I broke it into a left side, right side. I located my variable here on the left. What's being done to that variable? It's being multiplied by -4. I know that the opposite of multiplying by -4 is to divide each side by -4 to get those 4's to cancel out. And then in my Desmos calculator, all I did was 64 divided by -4 and got -16. And then the other two that we had, the one on the left here says -10 is equal to n divided by 6. So again, I broke it into a left side, right side. I found my variable and coefficient. I know that the inverse or opposite of dividing by 6 is to multiply each side by 6. Again, just because the variable's on the right side doesn't change how we solve the problem. The variable is being divided by 6, so I multiply by 6. Whatever I do to one side, I do the same exact thing to the other. 6 times -10 is -60. And then the last one here, x minus 12. Again, I broke it into a left side, right side. I located my variable. I said what's being done to that variable? It's being subtracted by 12. Well, how do I get rid of a -12 or a -12? Well, that would be to add 12 to both sides. That'll get rid of the 12, and then in my Desmos calculator, I would do -24 plus 12, and it would say -12. Okay, so at this point, make sure you have all of those examples into your notes. Now, Today, like I said, we're going to be working on what are called two-step equations. But the good news is the same rules that we used last week are the same rules we use this week. So our goal is still to isolate that variable. That means to get the variable by itself. At the end, we want to either have an x equals or something equals x. We're going to do whatever we do to one side. However, we're going to get that variable by itself. Whatever I do to that variable side, I have to do the same exact thing to the other side. We call that the golden rule. And how we do that is using inverse or opposite operations. And as always, you can plug your answer back into your equation to check for accuracy. So I'm going to do 3 examples with you. Here is the first one. So make sure you have this first one all set up and ready to go. So the first thing I want to do is read this problem out loud. Now, you'll notice that when I read this problem out loud, I'm going to say 2 operations, not just one like what we worked on last week. So in this problem, we have 3 times x minus 14 is equal to 58. Notice I said 3 times x, and I also said minus 14. There's my 2 operations. However, to solve this, I'm going to do exactly what I taught you last week. We're going to break the equation into a left side and a right side through the middle of the equation. I'm going to locate my variable, my coefficient, and any symbols that go with it. So I'm going to put a box or a circle around that 3x or 3 times x. Now, the goal is, this is always our starting point. I'm going to highlight this in blue. We always start out by canceling out the constant number. So remember, the constant number is the number that is not with the variable, but on the same side as the variable. So 3 times x, 3 is a coefficient, x is a variable. When I say minus 14 or negative 14, that is a constant number. It does not have a variable with it. So the first thing I want to do is do the inverse or opposite operation to my constant number. I have minus 14, so I need to add 14. Again, the golden rule, whatever I do to one side to cancel out, I do the other side to solve. So negative 14 and positive 14 or minus 14 and plus 14 cancel out. I'm going to drop down my 3 times x. And then in my Desmos calculator, I would just do 58 plus 14, which would give me 72. But notice, unlike last week, I still don't have my variable by itself. I still have 3 times x. So now I have to get rid of my coefficient. I'll get rid of my coefficient by doing the opposite of multiplying by 3, which is to divide each side by 3. And again, whatever I do to one side to cancel out, I do the same thing to the other side to solve. And then I go over to my calculator, I do 72 divided by 3, and I get an answer of 24. So we would say that x is equal to 24. So that's our first example. Second example, same thing. I'm going to read the problem out loud. I'm going to break the problem into a left side, right side, and then I'm going to use my inverse operations to get rid of my constant number and then my coefficient. So in this problem, I have negative 4 times x plus 2 equals negative 10. Here's my equal sign, so I'm going to break the problem into a left side and a right side. I'm going to locate my variable, my coefficient, and any symbols that go with it. So I'm going to put a box or a circle around the negative 4 times x. And then the first thing I want to do is get rid of the constant number. What's being done to negative 4x? It's being added by 2. So I know that the inverse or opposite operation of adding 2 is the subtract 2. Again, whatever I do to one side, I do to the other. To cancel out and to solve, I drop down what's inside my box, my negative 4 times x. Negative 4 times x now equals negative 10 minus 2, which is negative 12. So in my calculator, I just did negative 10 minus 2 to get negative 12. But again, I still have to get x by itself. What's being done to x? It's being multiplied by negative 4. So I know that the inverse or opposite of multiplying by negative 4 is to divide each side by negative 4. And again, the negative 4s will cancel out. I'll go back over to my calculator, do negative 12 divided by negative 4. And my calculator is going to say positive 3. So we could say that x is equal to 3. All right, last example before you're going to try some on your own today and roll into your classwork. Now this one may look a little bit different, okay? Remember, this is not a fraction problem. This is actually a division problem. So I'm going to read this one out loud. N divided by 4 plus 4 is equal to 12. Nothing changes, just the operation. So I'm going to break it into a left side and a right side. I'm going to locate my variable and my coefficient. Now I got to get rid of what's being done to n divided by 4. It's being added by 4. So I know that the inverse or opposite of adding 4 is to subtract 4. Whatever I do to one side to make it cancel out, I do the opposite, or I do the same thing, sorry, to the other side to solve. So I'm going to drop down n divided by 4. 12 minus 4 is equal to 8. But again, I still don't have n by itself. N is now being divided by 4, so the opposite of dividing by 4 would be to multiply each side by 4. That'll mathematically make the 4's cancel out and leave us with just n. Our goal is to get our variable by itself, which we have. And then the other side we'll solve by doing 8 times 4, which is 32. We could say that n is equal to 32. So make sure you have those 3 examples because they're the only 3 types of problems that we're going to be working on today. So at this point, I would like you to give these 5 a try. However, I would not take more than about 6 to 8 minutes. If you notice that time starting to run low on you, okay, so you got to take a peek at what time it is on your screen, I would try to work out as many of these problems in the next 8 minutes and see what you can get done, so that leaves you with some time to get your work done, your Bitly done. So pause the video, try some of these, see how you're doing. All right, here we go. Now I'm going to go over these. So the first one, I have 5 times b plus 3 is equal to 18. The first thing I want to do is I want to subtract 3 from both sides. That'll make these 3's go away. 18 minus 3 is 15. That'll leave me with b times 5. Equals 15. The opposite of multiplying by 5 is to divide each side by 5, and you should have got b equals positive 3 for this first example. The top middle one, I have w divided by 2 plus 6 equals 10. The first thing I wanted to do was get rid of my plus 6 by subtracting 6 on both sides. That'll leave me with my w divided by 2 equals 4, because 10 minus 6 is 4. The opposite of dividing by 2 is to multiply by 2, and then 4 times 2 would equal 8. Third one on the top, 3 times j minus 4 equals 14. Again, the first thing I want to do is get rid of my minus 4 by adding 4. 14 plus 4 is 18, so I could say 3 times j equals 18. The opposite of multiplying by 3 is to divide by 3 to get rid of the 3j, and then we would find out that 18 divided by 3 is 6. So we could say that j is equal to 6. Bottom left example, negative 2 times x plus 3 equals negative 1. First thing I wanted to do is get rid of my plus 3 by subtracting 3. Negative 1 minus 3 is negative 4. So now I have negative 2 times x equals negative 4. The opposite of multiplying by negative 2 is to divide each side by negative 2. And negative 4 divided by negative 2 is positive 2. And then the last one here, I have negative 2 times n minus 4 equals 22. Again, the first thing I wanted to do is get rid of that minus 4 by adding 4. 22 plus 4 is 26. So then I have to get rid of my negative 2 times n by dividing by negative 2. And 26 divided by negative 2 is negative 13. So hopefully you did a good job on those examples that you were able to do. So at this point, that is it for today's lesson. At this point, I want you to do your graded assignment that's below. So the Bitly's below. It's 8 problems just based on today's lesson. Should take you about 10 minutes, maybe a few minutes less, maybe a few minutes more, depending on how quickly you picked up today's lesson. Make sure that you show all work and all steps to get graded properly, and make sure you're using your Desmos calculator. And if you need any help, make sure you're asking for it as you go along.